Okay, imagine this. Go way back, like 3 million years. Picture one of our ancestors, maybe by a quiet pool of water, seeing a reflection, seeing something move only when she moves.
That moment, that first glimmer of self-awareness, it's kind of the ancient blueprint for intelligence itself, wouldn't you say?
Exactly. And fast forward to today, we're looking into another mirror, but this one's digital. It's AI.
Right. And weirdly, AI is turning out to be this incredibly powerful microscope, not for circuits, but for us, for looking at, the really unique, complex setup of human consciousness.
Yeah, let's really unpack this. We're diving into what some are calling the great AI paradox.
Hmm.
It's this massive contradiction, right? How can AI diagnose incredibly rare diseases, solve gigantic problems like protein folding,
Huge computational achievements, yeah.
but then it completely faceplants on stuff any 6-year-old can do without thinking, like understanding a simple joke or figuring out what to do when a traffic light is broken?
That paradox is precisely why we need to shift the conversation. It's not just about will AI replace us.
All right, that's getting old.
It is. The much more interesting question, I think, is what do AI's wins and its epic fails tell us about our own minds? How are we built?
Our sources are suggesting intelligence isn't just one thing, like a single score. It's more like an ecosystem.
Exactly. An ecosystem with different designs for different kinds of problems. And that's what we want to explore today, mapping that ecosystem by looking at AI as our mirror.
Okay, let's start with the AI side then, the conquests. Because yeah, honestly, some of the successes are just staggering. What are the big ones?
Well, the common thread is usually massive computational power plus access to just unbelievable amounts of data.
Like AlphaFold.
AlphaFold is a perfect example. Solved protein folding a 50-year grand challenge in, what, months? Then you've got the big language models, GPT and others.
Writing poetry, passing medical exams, translating languages.
And mastering games like Go and chess, finding strategies humans never saw.
They seem almost unbeatable in their specific lane.
Absolutely. They dominate when you have three things: clear, fixed rules, enormous data sets for training, and problems that just need sheer brute force computation way beyond human speed.
So that fits with what psychologists call crystallized intelligence.
Precisely. Crystallized intelligence is all about applying accumulated knowledge, facts, procedures to problems you've basically seen before.
It's the library, the knowledge base.
AI is like the ultimate tireless superhuman library. It never forgets, never gets bored retrieving facts.
Okay, but then the fault lines. We know it can beat the Go champion, but the sources paint a picture of AI really struggling in the messy real world.
Oh, absolutely. The transition from the lab or the game board to, say, a real business environment, it's often a disaster.
How bad?
Well, MIT researchers looked at enterprise AI projects. They're finding a shocking 95% produced zero measurable value. Zero.
95%? Wow. So the power doesn't translate.
It often doesn't translate into contextual utility, and it gets weirder. Apple scientists found their advanced models could suffer a complete accuracy collapse, meaning they just fall apart if a problem gets even slightly more complex or ambiguous than what they were trained on.
And isn't there also that paradox with the really big models that they start making things up more?
That's the OpenAI finding, yeah. As the models get more sophisticated, better at reasoning in some ways, they actually hallucinate more. They generate plausible-sounding nonsense.
So, okay, the contrast is stark.
Mm-hmm.
AI, amazing, with fixed rules, tons of data, pure calculation, human world, messy, adaptive, contextual, and AI often fails spectacularly.
And that failure, that's what really highlights the unique strengths of our way of thinking, our adaptability.
Which brings us to the next part. What do those AI wins tell us about our own limitations, like AlphaGo?
Right. AlphaGo didn't just beat Li Xiao, it played moves that were alien. Moves no Go master in 4,000 years had ever thought of.
That's genuinely humbling, isn't it?
It really is. It shows that when it comes to pure systematic pattern spotting in a defined space, our biological brains, well, they have limits. AI can process and see patterns in ways we simply can't.
And it doesn't get tired or distracted, right? Image recognition systems.
Yep.
They just keep going consistently.
Exactly. They are phenomenal engines for that crystallized intelligence we talked about. But,
Really?
and this is the crucial turn, while AI's success shows our limits in that area, the way AI learns highlights where we excel.
Ah, the learning difference. This is fascinating. AI needs, what? Millions of pictures to reliably know what a cat is.
Millions, sometimes billions of examples to generalize robustly.
Whereas a human toddler.
Sees a cat maybe 2-3 times. And boom, they get catness. They can recognize cartoon cats, real cats, cats in weird lighting.
That's incredible efficiency. How do we do that?
Well, the theory is we use these things called fast and frugal heuristics, mental shortcuts.
Like rules of thumb.
Kind of. They evolved to save us time and energy. We don't aim for perfect, computationally expensive analysis in every situation. Instead, we make good enough decisions really fast based on limited information.
Like you see stripes, big shape, pointy teeth.
Yeah,
Run first, analyze later if it wasn't actually a tiger.
exactly. It sacrifices perfect accuracy for speed and adaptability, which is crucial for survival in a dynamic world. AI, trained on massive static data sets, isn't really built for that kind of rapid, good enough adaptation.
So our minds aren't just less powerful versions of AI. They're structured differently, layers built up over time.
That's the idea, a layered architecture. Which leads us into the really deep distinctions.
Okay, let's get into those layers. The first idea is that human thinking isn't just happening inside our skulls, right? It's hybrid.
Yeah, the hybrid mind concept. It's the idea that our cognition is this constant interplay between our brain and our external environment, our tools, our language, our culture, shared stories, symbols.
Things that AI just doesn't have access to. It's stuck inside its training data.
Precisely. And the absolute foundation for that hybrid system is our episodic memory.
Not just knowing facts, but remembering specific experiences. Like that hominin by the pool, remembering the light, the feeling.
Exactly. It grounds our knowledge in lived experience. A data set is just data. It doesn't have that what it was like quality.
And human memory isn't like a video recorder, is it? I read it's more like rebuilding a scene with Lego bricks each time.
That's a great analogy. It's reconstructive. Every time we recall something, we rebuild it, maybe slightly differently, influenced by our current mood or goals.
Which is why we misremember things.
Right. But that bug is actually a feature. AI has perfect recall if it knows a fact. It's static. Our reconstructive memory lets us be flexible, connect past experiences to new situations in creative ways. It's adaptive.
Okay, so layer one, hybrid mind, grounded in reconstructive episodic memory. What's next?
Building on that is what we could call the embodied layer, particularly our ability for mimetic rehearsal.
Mimetic rehearsal, like mentally practicing something.
Exactly. Think of an athlete, a dancer, a fighter, visualizing their moves over and over again, or even just mentally walking through a difficult conversation you need to have.
Does that actually do anything?
Oh, absolutely. Research clearly shows that pure mental rehearsal leads to measurable improvements in actual physical performance. You're literally rewiring pathways in your brain and body.
So you're practicing being different, mentally, until it becomes physically real.
That's a perfect way to put it. AI can process endless information about skills, but it can't do that internal, embodied practice loop. It can't feel the movement internally.
Okay, that leads us somewhere deeper, doesn't it? The whole experience of time.
Yes. This might be the most profound difference. Human consciousness unfolds in irreversible time.
Meaning, you only live this moment once, no do-overs.
Exactly. What you do now changes the conditions for the next moment, forever. There's no going back to a previous save state.
And AI's power comes from escaping that.
Totally. AlphaGo played millions of games against itself, essentially rewinding time after every mistake. Language models process text over and over. They can operate outside that relentless forward flow of time that governs us.
And that explains why AI is great at games but struggles with, say, office politics.
Precisely. Games have fixed rules, repeatable scenarios, real life, work life. It's constant, irreversible flow. Every situation is subtly new, demanding adaptation based on past experience within that flow, not just pattern matching from static data.
So we use, what do the sources call it? Deep processing.
Deep processing, yeah. Reflecting, integrating experience over time, building wisdom. AI uses flat processing, quick input, quick output, without that temporal depth or experiential grounding.
In the final layer.
Yeah.
Meaning itself. AI can write about love,
Right.
but it doesn't feel love.
It manipulates symbols incredibly well, but it lacks subjective experience. It doesn't know what it means to love or fear or hope.
And humans. We
Yeah.
create meaning using symbols but differently.
Yes, through something called recursive semiotic mediation. It sounds complicated, but the idea is simple. We invent a symbol, like the word safety.
Okay.
Then that symbol, our own creation, starts to shape our behavior. We seek things that fit the safety label. We avoid things that don't. The source puts it beautifully. I create you the symbol to control me.
Wow. So the symbols loop back and guide us.
Right. And this lets us generalize concepts way beyond logic using feeling tone judgment. We mix emotions, experience, and symbolic understanding to navigate ambiguous situations where pure logic fails. AI doesn't have that recursive, feeling-infused, meaning-making loop.
Okay, so we've seen AI's power, its limits, and these deep layers of human cognition it doesn't replicate. Where does this leave us? What's the big picture for the future?
Well, the AI mirror reflects back two key things. One, our biological limits in certain tasks we're computationally slow and inconsistent.
Humbly, but true.
But two, AI's failures brilliantly illuminate our unique strengths. That temporal depth, the embodied learning, the hybrid mind, the recursive meaning making, our incredible adaptability.
Which explains that MIT finding, again, why individuals often succeed with AI tools where big companies fail.
Exactly. The individual isn't being replaced. They're supplying the crucial missing layers.
The context, the judgment based on lived experience, the understanding of irreversible consequences.
They're using AI as a powerful tool within their own much richer human cognitive ecosystem. It's a partnership.
So the future isn't replacement, it's complementarity,
Mm.
augmentation.
Absolutely. It's about figuring out the right division of labor for these fundamentally different kinds of intelligence.
Okay, so what's AI's role in that partnership?
AI handles the heavy lifting computationally, finding patterns in massive data sets, optimizing complex systems with clear rules, synthesizing huge amounts of existing knowledge, that crystallized intelligence stuff.
It does the brute force calculation and memory work,
Perfectly suited for it.
and the human role.
Our role stays rooted in navigating time, making judgments in ambiguous contexts, constructing meaning, creative problem solving. Basically, handling the fluid, adaptive challenges where the rules aren't clear and experience matters more than data. Intelligence isn't one thing, it's an ecology, different minds for different niches. AI is brilliant in its niche of well-defined computational problems.
And human intelligence, especially our fluid intelligence, the ability to reason through novel problems, is built for the messy, unpredictable, meaning-drenched real world.
We're still that hominin by the pool in a way, but now we see the reflection is so much deeper layered with memory, embodiment, culture, time.
And AI, far from diminishing that, actually helps us see just how complex and irreplaceable that human architecture really is.
By showing us intelligence without meaning, without subjective time, without embodiment, AI inadvertently highlights the incredible sophistication of what we do every day without even thinking about it.
So perhaps the real challenge isn't fearing the machines, but learning how to orchestrate this collaboration, using AI to amplify our uniquely human capabilities.
That's the goal, I think, to enhance human flourishing. Maybe AI's greatest gift in the end is simply showing us more clearly what we've been all along.
Irreplaceable architects of meaning, navigating an irreversible flow of time.